Okay, we're going to do a couple more examples here of ln integration, or not, right? I'm trying to show you the difference between when we should use it and when we shouldn't. So for this one, it's a continuation of what we've been doing, integral. In the top, I'm going to put my 10x plus 1. In the bottom, I'm going to go square root of 5x squared plus x with a dx on the outside. So you might look at this and say, oh, it's an ln of the square root. Nah, here's why. Same u as before, 5x squared plus x. Find the du. It's 10x squared plus 1 with a dx. And then I sub everything in. So I get integral. My du is in the top. And then notice there's no square root here. So it's root u. And now this one can be rewritten as the integral of u to the negative half du. And you should see, just like with some of these other ones that I've been trying to point out, um, this one is also a power rule problem. It's also a power rule problem that's often messed up. So part of why I'm going over it. If I go up 1 from a half, I get to u to the positive half. And then I need to do 1 over that number, that new power, half, plus a c. Notice I'm dividing by a fraction, so there are all kinds of ways that people talk about it. Multiply by the reciprocal, copy dot flip. You can multiply by 2 over 2. All those are good, but I get 2 in the top, and then I get a root u plus a constant. And then I can sub back in. Whoops, why am I writing a u? That is equal to whoops, come on, 2 square root, what's u? 5x squared plus x plus a constant. Okay, we're going to do a couple more that look a little bit different now. This one is going to be a definite integral. All right, here we go. Integral from 1 to e, fraction bar, top, open parentheses, 1 plus ln x, close, denominator, x, with a dx on the outside. So this one, actually, you don't really need everything. Like this is not really new for you. You should have been able to do this before today, but this is just a good time to slide this in. What I want you to see is that, do I want to rewrite this a little bit so you can see it a little bit better? You might already see the u sub, integral 1 to e. I'm going to write ln, or sorry, not ln, come on, 1 plus ln x times 1 over x dx. I just moved this out so it's in between these two pieces. And I think you should see that I got an ln here and a 1 over x dx. So I'm going to make my u equal to 1 plus ln x. The reason I do the 1 plus ln x because I want u to typically be as big as possible. That makes du equal to 1 over x dx. So subs, this is that, and this is that. So here is something that I am not going to write an equal sign. I'm just going to write integral of u times du. I'm not going to write these two are equal, and it's a subtlety that I haven't really gotten into yet. That has to do with u subs when we have these definite integrals. So just this is kind of like some scratch side work. What is this equal to? 1/2 u squared plus c. So now what I'm going to do is come down here and write. All right, I got 1/2. Open parentheses, what was u? It was 1 plus ln x, close, I'm doing this, squared, evaluated from 1 to e. All right, and now I'm going to come right here and write equals. This is 1/2, and then I'm going to open a bracket, something squared minus something squared, close bracket. All right, here I got 1 plus ln of x, but evaluated at e, and then minus 1 plus ln of x evaluated at 1. So hopefully we've done some review recently with how to do this. This guy is 1, ln of 1 is 0. So really this is 1/2, open bracket, well, parentheses, I got 2 squared, so I got 1 plus 1, and then 1 plus 0 minus 1 squared, which gives me 1/2. That's 4 minus 1, so it's 3, so I get 3 halves. Okay, let's go ahead and do a couple more here. Let's do the integral, and this one's funky, and actually I should just write it. 1 over x times ln, open parentheses, x cubed, close, dx. So the way that this is currently written is kind of like it doesn't lend itself to like quickly integrating or finding a u or a du. We'll talk about some of the things that I see. I see a 1 over x right here. And I'm like, And then I see an ln. And I know that ln derives to 1 over x. So maybe this 1 over x is part of my du and the ln. But then I got this x cubed. And I'm like, ooh, ln x cubed? What's that derive to? And I think chain rule. It's like, whoa. But there's a rule that I've taught you that simplifies this problem significantly. We can move that 3. Do you see how we can move that 3? It's the Plog rule. Remember, this right here, whoops, maybe I'll do it in a different color. This can get moved out here. And then once I move it out here, I can actually move it out here into a 1 over, right? So what I'm going to do is use the Plog rule to get that 3 out of the way so that I can then go and do some u sub. So this is the same as 1 over 3 integral 1 over x times ln of x dx. And then at this point, I can say, all right, I'm going to let u equal ln x, and then du is 1 over x dx. The pieces are a little bit broken up, but this, and this are all that. And then this is that. So I get 1/3, and then I got my du integral. That's this stuff in the top. Why is it still in the top? Because it's in the same, it would have to be a flip version of this, right? Over, all right, think about this. ln, so it's u. Whoa, this is weird. All right, so this is 1/3. What's that? Oh, that integrates to an ln, absolute value of u plus c. And then from there, I plug my u back in, and u is, this is kind of poorly written. Let me fix that. That looks better. But I integrate using an ln, but remember my u was an ln. So what do I get here? Ooh. I get 1/3 ln absolute value. U is another ln of x plus a c. I think it may be a little confusing. Should this be an absolute value? And the answer to that question is no, because remember, u was an ln. There was no absolute value here. We only get the absolute value from the actual integration. All right, so I'm going to stop there. I'm not going to do any more examples. I'm going to send you off to go do some problems on your own. But just to quickly refresh, we did a lot here. We did some u sub anti-set stuff. We practiced that. Hopefully you're good with that. We talked about the derivative of ln and then what the integral of 1 over x is. We did some simple examples. We threw in some definite integrals. Hopefully you're remembering how to do those. And then we did a whole bunch of examples that have these fractions that look like some might be ln integration and some might not, and you need to figure out when the appropriate time is to use each of them. So hopefully you're feeling pretty good with this, and I'll see you soon.